Good evening to everyone. I'm Suryanarayana, working as an assistant professor in DBS Institute of Technologies. Today in this class, we will discuss about Unit 3 in CAD/CAM subject, which is for mechanical engineers of final year first sem. This Unit 3, I'm sharing my PPT to you. First of all, presentation on CAD/CAM subject. After that, Unit 3 named as numerical control, which is in subject CAD/CAM. First of all, what is numerical control and what is the definition for numerical control? Okay. First of all, the definition for numerical control, it is a system in which actions are controlled by the direct insertion of numerical data at some point. Here in this, the numerical data, that means it is the data that is to be measurable, such as length, height, weight, time, etc. In other words, it will be defined as programmable automation in which the mechanical actions of a machine tool are controlled by a program. Here in this above definition, below definition, those are two says that about only one word, that means the machine tools which are controlled through giving numerical data to numerical controller. That means here the machine or the machine tools are controlled by means of commands in the form of NC codes. Okay. After that, here I am showing the cycle which is in numerical control process. I am showing a procedure for numerical control here. The cycle which starts from manufacturing operator and ends with processed part. First of all, I'm starting with manufacturing operator. Okay, first of all, manufacturing operator. The manufacturing operator gives the numerical data, that means properties of materials, what is the material type, and coordinate system, x-axis, y-axis, z-axis, directions. After that, feed rate, depth, spindle speed, etc. Those are all data. That means those are numerical data will be given to numerical controller in the form of NC codes. After that, giving the numerical data to numerical controller, the data will be, that means the new NC codes or commands will be directed or converted or translated to machine unit. That means here first of all I am giving, here assume I am the manufacturing operator, I am giving the numerical data to numerical controller in the form of NC codes. First of all, I am giving the data in the form of NC codes to numerical controller. After that, numerical controller converts the data, directly converts the data to mechanical actions. Okay, NC commands or NC codes are directly converted to mechanical actions. That machine unit consists of many number of parts. First of all, tables, jigs, fixture. First of all, taking drilling process, it consists of drilling tools, drilling bits, etc. Machine unit consists of more number of parts. Okay. After that, all process will be completed. Final part, that means final processed part will be produced. This is the procedure for giving the commands and how the final part will be produced. This procedure will be followed for numerical control process in industrial areas or outside areas. This is the basic figure for numerical control process in industrial areas. Here, first of all, the highlighted part, that means the highlighted rectangular box will be numerical controller. In this numerical control, we are giving NC codes, that means the controlling or the coordinate system, x-axis, y-axis, z-axis, that means the axis system will be given translational or rotational. Translation is nothing but linear actions. After that, rotational will be rotational axes, x-axis, y-axis, z-axis. After that, giving all commands to NC control unit, machining operations will be started. After that, all parts will be known to you: head stock, carriage, tool post, tail stock, 3-jaw check, 4-jaw check, all systems. Those are all we are studied in lathe machines. Next, here the basic principle is nothing but here we are giving the NC codes to numerical controller. After that, numerical controller will be converted the NC codes to mechanical actions. What will be required here? Next, coming to components of NC machines. Components, that means elements. Elements of NC machines, first of all, MCU. MCU is nothing but machine control unit. After that, machine tool. Those are all clubbed with CLU and DPU. CLU is nothing but control loop unit. DPU is nothing but data processing unit. First of all, we will start with machine control unit. What is machine control unit? It is the heart of NC controller. That means NC machine tool has a main unit which is known as machine control unit. It consists of electronic hardware that reads the NC program. That means first of all we are giving NC program to NC controller. After that it interprets and conversely translates it for mechanical actions of machine tool. Already I told you, that means we are giving NC codes to numerical controller. After that, numerical controller, it will be given to machine control unit, MCU. MCU consists of more number of parts here. NC codes will be directed to machine control unit. Machine control unit cuts or translates to mechanical actions of machine tool. That means what is the requirement to be drilled or to be shaping. Okay, what is the requirement for us? Those are all will be done by using machine control unit. A typical machine control unit may consist of following unit. That means input or radar unit, memory, processor, output channels, control panel, feedback channel. First of all, I am starting with input or radar unit. Input or radar unit is nothing but we are giving. That means I am the manufacturing operator. I am giving the numerical data. That means NC codes will be given to numerical controller. After that numerical controller, it will be directed to machine control unit. In machine control unit, the process, that means the phase starting with input or radar unit. Here we are giving NC codes to machine control unit. It is nothing but assume it is a computer. It is the CPU for the computer. Okay. Input means nothing but here we are giving the data in the form of NC codes. Memory. Second one is memory. Memory is nothing but it is a storage. Okay, we are giving NC commands. Those are all commands will be stored in memory part. After that, processing section. Processor is nothing but processing section. Output channels, control panel, and feedback channels. Output channels, control panel. Control panel is nothing but checking section. Here in this, any errors are there. Okay, any errors are there. We are solving by using control panel. Here feedback channels. Feedback channels is nothing but after that feedback channel is the ending part of machine control unit. Starting part is input, final data, that means converting or translating data will be given to machine tool. After that, first of all, we are discussing with machine control unit. After that, we are moving to machine tool. Machine tool, it is the main component of numerical control system which executes the operations. That means it may consist of tables, tools, jigs and fixtures, motors for driving spindle, and coolant and lubricating system. That means it is the part. Okay, the total work will be done in this system. That means machine tool. The latest development in the numerical control machine tool is the versatile machining center. Versatile machining center is nothing but 360 degrees rotation of check. Okay, versatile is nothing but 360 degrees rotation of machining center. Machining center is nothing but check system. This is single machine capable of doing number of operations. That means many number of operations done at a certain such a time. That means at a time we are doing same operations or different operations. That means milling, boring, drilling, reaming and tapping. All operations done at a time by using automatic tool changer. That means ATC under the control of tool section instructions, etc. Okay, it is the latest development in numerical control machine. All operations will be done by using automatic tool changer ATC. Next, the MCU may be of three types. One is housed MCU, second one is spin around MCU, third one is stand alone MCU. First of all, I'm starting with housed MCU. Housed means the answer for this housed MCU is nothing but it is a machine control unit. It is mounted on the machine tool, not on machine. It is mounted on machine tool. Coming to second one, swing around MCU. Swing means in this the machine control unit is directly mounted on the machine. Students, see the difference between housed MCU to swing around MCU. The major difference between housed to swing around MCU, in housed MCU we are fixing or we are mounting the MCU on machine tool in housed type. In second one, swing around MCU, we are mounting the MCU on machine, okay, which can swing around it, can be adjusted as per requirement. Okay, coming to third one, stand-alone MCU. In stand-alone MCU, machine unit is enclosed in a separate cabinet. Okay. Okay, I'm reading three types of machine control units here. First of all, housed type. In housed type, we are fixing or we are mounting the machine control unit in on machine tool. In swing type, we are mounting on machine. In standalone MCU type, we are mounting in a separate cabinet. Okay, we are mounting or enclosing in a separate cabinet. It is standalone type. These are the different types of machine control units, three types. Other components of an NC machine tool: controller, Okay, the process starts from controller. Here we are giving commands to controller in the form of NC codes. After that, servo drive. Okay, after that, all commands or all codes will be given to servo drive. Servo drive is a system. All commands will be given to servo drive. Servo drive moves the system. That means it consists of gears, etc. Those are all commands will be given. We are giving in the form of NC codes. The MCU, machine control unit, converts the NC codes to mechanical actions. Here servo drive will be started here. After that, all action will be given to motor. It is an electric motor. Next, tachometer. Tachometer, which is used for measuring the speed in RPMs, revolution per minute. Next, gearbox, machine table, position transducer. Transducer is nothing but measuring for changes. Here, position changes. Those are all the other components of NC machine tool. In this, the main part is servo drive here. Servo drive, which consists of number of parts and gearbox. The cycle starts from servo drive. Servo drive moves the motor. Once the motor will be turned on, the process will be continued by using of gears. By using gearbox, we can change the velocities and speeds of spindles or lead screws, etc. Next, coordinate system. What is coordinate system? Coming to lathe, we are following right hand rule or left hand rule. Here, first of all, I am discussing with right hand rule. Okay. In first figure, I am showing work. Assume it will be work part. In this, I am showing plus x. Right side will be plus x, left side will be minus x. After that, above part will be plus z, below part will be minus z. This is the coordinate system. I am following right hand rule. So for that cause, the right hand section will be work part, right hand section will be plus z. The left handed, that means I am following here right hand rule. For that cause, the left hand side will be negative. Automatically, the upward direction will be plus z, positive direction. The below or downside, downgrade section will be minus z in negative words. In second figure, I am showing the difference by using carriage section. Here, the carriage complete in lathe machines, the main center in middle section will be called as carriage. The carriage or tool post will be moved in right side. That means moved in right side, it will be positive direction plus x. Because of we are following right hand rule. In case we are following left hand rule, the after that, here the right hand rule. That means in case of we are following left hand rule, the left hand rule will be The tool post, that means the tool post will be moved in left hand direction. In case here we are discussing in right hand rule, in case we are following with left hand rule, the movement in left side will be positive direction, the right hand movement will be negative direction. Okay, assume. Next, depth of movement, that means depth will be minus z plus z. After that, assume milling and drilling operations. Next, coordinate system. The third and fourth operations will be coordinate systems. Assume milling and drilling operations. Next, basic requirement of NC machine control. What are the basic things in NC machine control unit? Preparatory functions, coordinates, machining parameters, tool controls, cycle functions, coolant control, miscellaneous control, and finally interpolators. First of all, I'm starting with preparatory functions. Preparation is nothing but starting functions. Which unit we require, which interpolator we are using. We are following absolute or incremental direction, or we are following absolute or incremental dimensions or programming, which interpolations are following, which cutter compensation we are giving. Okay, these are all things will be discussed in preparatory functions. Next, coordinate system. 3 translational and 3 rotational axes. That means translation is nothing but plus x, y, z. Those are all translational. That means linear movement of actions. Rotational means movements x, y, z. Rotational axes. Machining parameters. What are the parameters will be given to NC control unit? That means speed and speed. Next, tool control. Tool control. In tool control, we are discussing tool dia, tool numbers, tool changing. What is the tool number? If we require, first I am starting with the drilling operation. Okay, starting with the drilling operation, I am giving the notation for drilling bit. It is tool number 1. After that, in case I am starting or I'm changing drilling operation to milling operation, milling tool will be 2. Okay, noting or give tool numbers to all operations will be easier to done or automatic changing by using automatic tool changer for fasting production. Here, cycle functions. Cycle functions are nothing but drilling cycle, ream cycle, bore cycle, mill cycle, clearance plane, etc. Coolant control. Coolant control is nothing but if we require coolant or not, yes or not, in type of flood or mist. Miscellaneous controllers here. Miscellaneous is nothing but spindles, on or off, tape rewind, spindle rotation, etc. Interpolators are nothing but linear or circular interpolation. Those are all the basic requirements of NC machine tool. Next, NC machine control. The cycle starts from NC program and it will be given to execution system. The execution system will be checked in 2 classifications. One is dimensions and second one is command. The dimensions will be checked in interpolator or servo control mechanism. That means dimensions will be given to servo control mechanism. After that, control logic. Next, linear motions. Here it is related to dimension part. The second classifications will be command. Okay, we are giving NC codes or commands to programs. Sorry, commands. Next, translator. That means we are giving NC commands or NC codes to numerical controller that will be directed in machine control unit and translated to mechanical actions. Translator used for converting the NC codes to mechanical actions, relay and solenoid. Solenoid is nothing but it acts like a switch, and then power will be given to control logic and linear motion will be started. This is the cycle for NC motion control. Okay. Next, new NCs or CNCs. Different types of classifications will be given here. High speed spindle, high feed rate drive, high precision. If spindle speed will be more than 20,000 RPM, it will be called as high speed spindles. Next, high feed rate. In high feed rate drive, the IPM input per minute will be greater than 600. Precision, high precision will be less than 0.301 accuracy. Those are the new numerical control machines or CNCs, computer numerical control. Types of numerical controls. Types of numerical control. In this numerical control, 3 classifications are there. One is conventional numerical control type, and second one is DNC, that means direct numerical control, and third one is computer numerical control. Okay. First one, coming to first one, conventional numerical control. In this, data is sent to machine tool by means of punch cards or tapes. That means here we are giving the data, that means NC codes, by using punch cards or tapes. The reader at the machine performs no calculations or interpolations here. In numerical controller, it is the conventional type numerical controller. The codes, the NC codes are input given to machine control unit in the form of punch cards or tapes. In this, the reader, it is inside of machine control unit. The reader performs no calculations here. That is the conventional type numerical control. And coming to second one, direct numerical control. What is direct numerical control? In DNC, control of multiple machine tools by single computer through direct connection and real time. Okay. Here, the numerical control will be directed by using of single computer. Two-way communications used here. Next, second classifications are also there. Distributed numerical control. One is DNC is direct numerical control. Second one is distributed numerical control. Network consists of central computer connected to machine tool. That means here one network consists of central computer. It is connected to machine tool MCUs, which are CNC. Present technology, two-way communication also used here. That means second type is one type similar to computer numerical control. And third classification will be computer numerical control. Computer numerical control is to position a computer right at the machine tool. That means here we are completely following computer. Most of time, if not all machine tools that are numerically controlled are CNC machine tools. That means in CNC machine tools, most of things, all machine tools are not numerically controlled. Some are following CNC machine tools. This is CNC. Here I am showing different types of CNC machines here. In second figure, I am showing ATC, automatic tool changer here. In automatic tool changer, that means is this center circle will be machining center. Different types of tools fixed here. By following automatic tool changer. Different types of tools will be machined at a time. Advantages of NC control: reduces time for delivery of a part, reduces scrap rate, reduces tooling cost, reduces layout time, and increases machining and tool life. First of all, reduces time for delivery of part. Why? Because I am telling that reduces time for delivery of a part. Why? Because we are following numerical control, not we are completely depending on manual labor. Here we are following numerical controls and machine controlling unit. That means the all procedure will be completed in machine control unit. That means we are giving only what are the requirements to given in the form of NC codes. Those are lengths, heights, okay, time, required part. Those are all the properties and particulars will be given in the form of NC codes or punch cards, tape readers, etc. Those are all the input will be directly converted to mechanical actions by using of machine control unit. For that reason, the production will be very fast by using latest versatile numerical controlling machines, and reduces scrap rate also. Scrap rate is nothing. Its wastage material is reduced by using numerical control, and reduces tooling cost. Why? Because tooling, wearing, tearing, those are all two terms will be reduced by using of numerical controls, and layout time is also reduced. Fixing or mounting time is also reduced by using of numerical control. Reduces storage problem. Why? Because here memory consists of more data. After that, the data will be shared to processor. Next, less setup time, reduces actual machining time, and less jigs and fixtures. Okay, jigs and fixtures, work holding devices, etc. This is the advantages. Okay, those are all advantages using of numerical control machines. Cost benefits of numerical control. Cost. First, starting with cost: high investment cost, high maintenance effort, need for skilled programmers, high utilization required. Okay, when it comes to cost particular, high investment cost. Why? Because comparing with manual type lathe machines to numerical controller machine, high investment, that means initial cost will be very high when it comparing to traditional type. High maintenance effort, maintenance is also very high when it compared to traditional or conventional type. Next, need for skilled programmers. Why? Because I'm telling that skilled programmers are required to for machining operation, because we are giving not on manual codes, we are giving NC numerical controller programs here. Numerical control programs given to NC controller. For that reason, we will require skilled labor here. High utilization required. Resources are required for machining operations. Coming to benefits, first of all, cycle time reduction, non-productive time reduction, lower scrap rate. Previously I was told to you, scrap rate is reduced by using of numerical controlling. Operator skill level reduced. Benefits or cycle time, lower scrap rate, operator skill level. Those are all the benefits. Okay. Classifications of numerical control. This is nothing but NC modes. NC modes will be discussed in next class. Okay. Thank you.